Familiar with some of the probability notation and terminology, let's start adding a little bit onto that. The first thing we're going to add on is this idea of conditional probability. And it's the idea that we're finding the probability of an event given some extra information. So instead of looking at the entire sample space, we're going to narrow it down to a smaller given piece of information. We're going to need some special notation to denote this. So we're still using probability of A, but now instead of just probability of A, we're going to denote that we have some additional information to help us out. So we're going to use this vertical line to mean given. Don't draw this as diagonal or a dash or anything else, just like this. Probability of A given some extra information about B. So you would read that as probability, I'm going to abbreviate that here, probability of A given B. So the given information always goes second or after the line. So if you have a table, for example, you don't really need any special formulas. You can just think about this a little bit. The first one, this data should look familiar, our home team advantage across different sports. So here, we want to find the probability that a randomly selected game is won by the home team, given it's a basketball game. So we're given some extra information. We're given the information that we're only looking at basketball games. So I'm going to use that vertical line because I've given information. And after the line, I'm going to put a B because my given information is that we're talking about a basketball game. So given info always goes after the line. And we're interested in finding the probability the home team won. So that's what I'm curious about, probability of home team winning given this information that we're only looking at basketball games. So no formula is needed. If I'm just talking about basketball games, I can kind of ignore all of this other stuff, and I'm just looking at this column of basketball games. So now I've narrowed down my sample space. Instead of all 490, I'm looking at 198 basketball games. I've narrowed it down to 198. And out of those, 127 were won by the home team. You are totally welcome just to leave it as is, or you can go ahead and work it out as a decimal for comparison, which would be 0.6414. And just kind of a quick side note, so given we're talking about basketball games, home team advantage is pretty strong. The home team wins about 64% of the time. Over here, the home team won across all sports about 58% of the time. So we can definitely see the home team advantage is stronger for basketball games, 64%, versus just generally at 58%. Let's check out a second example. It's going to be worded a little bit differently. Of the games won by the visiting team, what's the probability of it being a football game? Think for a moment and figure out what is our given information. Right, hopefully you noticed that our given information, we're not talking about all the games, we're talking about of those won by the visiting team. So that's my given information, and that's going to go after the line, visiting team. Then, what we're curious about finding the probability of is the probability of a football game. So probability of football, given we're only looking at games won by the visiting team. So same thing, looking at our data table, I'm given or narrowing the sample space from all 490 just down to those won by the visiting team. So looking across at the visiting team, we have 203 games where the visiting team won. So I've narrowed my sample space down to those. And out of those 203, 42 happen to be football games. And if we work that out as a decimal, we should get something like 0.2069. All right, so you can see if your data is in a table, you don't really need to work too hard to find these conditional probabilities. We write the given information after the line, and our denominator changes accordingly according to that given information. Sometimes it might not be quite as clear if we have more of a word problem type question. So let's check it out here. Our formula for conditional probability. The probability of A given B is going to be the probability of both of those events happening, A and B. And I'm going to divide by the given information. So this is why notation is very, very important. The denominator is always the part that's after the line right here, or our given information. Okay. So let's check out some examples to apply this. And maybe let's start with a less wordy one down here at the bottom. So they tell us 32.9% of anglers fished in salt water. So remember the suggestion. If you have a word problem, translate all the information into probability notation. So probability of salt water, so I'm going to use S for salt water, is 0.329. Keep reading, 78% fished in fresh water, so probability of fresh water is 0.782. Notice I'm writing these all as decimals. Make sure you do that. Probabilities, we said, are decimals between 0 and 1. And then they also tell us 11.1% fished in both fresh and salt water. So notice our keywords here, both of these overlap. So we want to do that notation, S and F, both. And that was the 11.1%. Now our question, let's translate that into probability notation. Given, so there's our key word, we're going to need that vertical line, that an angler fished in salt water. So let's jot that down. Given, and the given info always goes after the line. So given salt water, what's the probability he or she fished in fresh water? So the probability I'm interested in finding is fresh, but I'm given that this person also fished in salt water. So our formula tells us to do the probability of both of these things, fresh and salt. And we're going to divide by the given information. So we're given salt, so the denominator needs to be salt. We know all this information nice and tidy over here, so let's just plug that in. The both part was the 11.1%. The salt was the 0.329. And if you work that out, you're going to get something like 0.3373 if you round to 4 decimals. And if you had this flipped around, you would know something was wrong, for example, because you'd get a number bigger than 1. So, look for all those clues. Let's try one more example on conditional probability. So this example, a little more wordy. 71% of students graduating from a 4-year college had student loan debt. So again, let's do our translations first. Probability of debt is 0.71. I want to know about those lucky 29% that don't have debt. I was not in that category. Then they tell us 73% attended public university. So probability of public university, 0.73. And then 48% graduated with both debt and public university. So there's our key word here, the both or the and part. So both of these things happen. So probability of debt and public was a whopping 0.48. Now here's our question. Of those who attended public universities, so notice that language, it's not speaking about all college students. It's only speaking about students that went to public schools. So probability of those that went to public schools, so that's our given information. Probability of public What percent graduated with student loans or debt? So there's our question. Take a moment on your own. Let's try and set this up. Okay, remember our formula is the probability of both. And you're going to divide by the given information. So our given information is the probability that someone attended a public university. And let's work that out. We've got all the numbers nicely denoted over here. 48 were both. Public was 73. And that's going to give us our 0.6575. Okay. All right. We're going to look at a variation of this in our next video, so make sure and rewatch anything if you need to, you understand this before moving on.